Hello, my name is Paul Thomas Everett Cusick. I'm an engineer by education, but I do research in just about every area that universities teach in. Today's paper on chemistry is about concrete, which is pertinent to civil engineering. So the name of the talk is called Concrete and AT Math, or Astrotheology Math, from Observation to Theory. In this paper, we calculate the variables for regular concrete that have been observed but not put on a mathematical basis. Concrete is widely used and is an important building material. Understanding concrete better is important considering that a lot of infrastructure repair work in the United States will be done in the short term that has been neglected for far too many years. Concrete repair is a large part of that work. Civil engineers study concrete in great detail, but to my knowledge, the theory undergirding the measurement of variables for concrete, such as 28-day strength or the water to cement ratio, has never been done before. Using the new physics, astrotheology math, uncovered again from ancient times, the Babylonians, the Egyptians, the Indians. By this author, we calculate the parameters that are essential to understand concrete fully. We begin with astrotheology theory. Here we briefly consider the theory of astrotheology developed by this author, myself, to solve mathematical physics problems. However, the AT math solution is applicable since it involves the convergence of physical mathematics, which is at the heart of astrotheology mathematics. For concrete chemistry, it's quite complicated. So we have tricalcium silicate plus water yields calcium silicate hydrate plus calcium hydroxide plus heat. And that heat, that 173 joules, is important. Concrete doesn't dry. It's a chemical reaction called hydration. And it produces heat from that chemical reaction that occurs forever in the concrete, as long as there's water. So the second equation there is here is dicalcium silicate plus water yields calcium silicate hydrate plus calcium hydroxide plus heat. So there's the second amount of heat. So we'll see that heat adds up to 23.3, I think it is, which is the ln of pi, and we'll see how that's important in another slide later down. So the method used in this paper is a desktop investigation of known variables such as 28-day strength, water to cement ratio, the air entrainment in mortar, heat of hydration, and the manufacture of cement in a clinker was undertaken. Then AT math was applied to the physics and chemistry of Portland cement. Astrotheology has formulas and known parameters that were used to compare against those observed for concrete. So we're putting concrete material science on a theoretical basis rather than just the observation. It's from observation to theory. So the molecular mass of concrete is 2 calciums. We have 2 silicones, 2 oxygens, 14 hydrogens, and they add up to 7 O's, oxygens, and they add up to 26.14, the molecular mass. This is Avogadro's number. That's the molecular mass. Molecular mass and Avogadro's number is 26.14. So the mass is equal to the ln of T. So we put this figure 26.139 equals the ln of T, and T is equal to 13.65. So energy is equal to 1 over T, which is equal to 732 plus 173.6 equals 2.472. And e to the T is equal to e to the 2.72 is equal to 118.461. which is equal to 1 over 844,158. So then we have Poisson's ratio is 0.84 times the mass lateral over the mass axial is 0.26. That's the Poisson's ratio for the universe. So the mass lateral over the mass axial is 0.308. 0.308 is equal to 1 over 13, which is equal to 1 over E. And E equals 13, so there's a formula for mass theology is E squared plus E minus 2 is equal to T. 13 squared plus 13 minus 2 is 180, which is equal to pi. So that's another variable for mass theology. So we have 0.26 Poisson's ratio times 8/3, which is a superforce, is 0.693, which happens to be equal to the ln of 2. So since the mass is equal to ln of t, that t is 2 right there. And we plug the 2 into the golden mean parabola, which is another formula for mass theology. We have 2 squared minus 2 minus 1 is equal to 1. So we have the point t of 1 minus 1 or 2 is for the value of t. So we have 0.693 times 8/3 is equal to 1443. E to the 1443 is equal to 1.15, which is equal to 1 over sine of 60 degrees, which is equal to E. We take the other formula from astrotheology mathematics. The cross product of energy and time yields space, which is equal to the magnitude of E times the magnitude of T times the sine of theta. That's when space equals time, energy is equal to just simply 1 over sine theta. It's an important formula for astrotheology. So here is a plot of the ln function, the exponential function. This is that mass ln function. And this is the e to the minus t function. And basically the important number here is when t is equal to 1, which drops out from astrotheology. Time is equal to the kinetic energy, which is equal to 1/2 mv squared. 1/2 times 4 times 3 squared is 18, and 18 is equal to the kinetic energy. And time runs to pi. This is a critical point. That's a diagram that's very much applicable to astrotheology. So the strength of the concrete, mass is equal to the ln of t, energy is equal to 1 over t, which is equal to 1 over f, because force and time are equal. Their force and time are equal. These two formulas come out of astrotheology. So mass is equal to the ln of f. Ln is equal to 20 megapascals for concrete, which is 2.9957, approximately equal to the speed of light. That implies y equals y prime. So when you have y equal y prime, we take the function, the golden mean parabola, t squared minus t minus 1, and set it equal to the derivative, which is 2t minus 1. Set those equal, t equals 3, energy is equal to 5. So now we take a concrete test specimen, a concrete cylinder. They're 150 millimeters in diameter and 300 millimeters high, or 6 inches by a foot. So the surface area is just calculated out to be 1, and 1 plus 707, which is 1 over root 2, is 17. So concrete is said to have 75% of its 28-day strength in 7 days. We can use the log strength formula to verify this. So 75% is 3/4, and S is equal to 4 over 3, so that's 3/4 is 1 over S at 7 days. The mass is equal to 1 over 81, which is equal to 0.012345679. So it'd be each one of those numbers is cresting of a seventh times 7 and then from 7 to 9 is 2. So it's a 7 times 7 is 1, plus 2 is 3, which is equal to our time. There we go there. The time that, and that implies that y equals y prime. So mass is equal to ln of t, dm by dt is equal to 1 over t, which is equal to, dm by dt is equal to 2, we know from master theology. So we know that t is equal to a half, which is the minimum for the golden mean parabola. When t is a half, E is equal to minus 1.25, which is the bottom of the parabola, the golden mean parabola. It's all part of the convergence of math. So we have dm by dt is 1 plus 2 equals 3, t equals 1 over 3, which is 33%. So 33% of 28 days is equal to 9.24 days. Ln of t is equal to the ln of 9.24, which is equal to 222, which is equal to 2 over 9. I'm sorry, 222 divided by 20 megapascals equals 111. This is 1/9. This is 1 over c squared. So if energy is 1 and potential energy is equal to mc squared, then 1 over c squared, energy over c squared equals mass. 4 times 1 over root 2 is 2828, which is equal to mv, which is 4 times 1 over root 2, which is momentum. And the ln is equal to pi minus 1, which is equal to 76.154, which approximately equals 75 days, where it reaches 98.4% of its strength at t equals pi. So concrete reaches most of its strength when time is equal to pi. So we have the change in heat is equal to 1.736, which is approximately equal to root 2 kilojoules. And we have the golden mean parabola here again is t squared minus t minus 1 equals e. So if we plug root 3 into that equation, we have root 3 squared minus root 3 minus 1 is 2.67, which is equal to the superforce. And energy is equal to 1 over the force, so force is equal to 1 over the energy. 1 over the energy is equal to the time. So the time is the same as the force. The force is equal to the time equals 2.67. And then the change in force is equal to the change in time. So here's your calculation of your time. It's kinetic energy, 1/2 mv squared is 18. Your delta T is 2.67 times 1 over 18 is 148.33. So we have 1.4833 times 24 hours a day. It's 356 days. So e to the 1.356 is equal to 7.00, which is 7 days. So concrete reaches most of its strength within the 7 days. And reaches almost all of its strength within the pi cycle. So the mass is equal to, as we've seen, 1 over 81, which is equal to 0.012345679. So there's your time is equal to 3. Delta T is equal to pi is 1 minus 2.1. Pi minus 1 is your delta T. That's from your function. Do I get this to work? Oh, I'm sorry, it's this. So this t is equal to 1 here. T is equal to 1 to pi, so pi minus 1 is 2.14159. So we have 2.14159 times 1 over the kinetic energy is equal to 118. 118 divided by 24 hours is equal to 0.495.7. And that will give E min, this is wrong here, this should be minus 1.25, which implies the golden mean parabola. And delta H1 is 173.6, which we've seen from those chemical reactions above, the heat of hydration. And then the second reaction is 58.6. So the delta temperature is equal to 23.19. The ln of 23.118 is equal to 3.1433, which is equal to pi. So here's the heat of hydration over time. There's a spike here at the beginning, first 15 minutes, and then there's a latent heat, and then it takes off, and after 12 hours it reaches its maximum height, then it tails off for the next 20 hours. So this formula here is just the Bell normal curve, this Bell normal, and we'll see that later. So 15 minutes plus 2 hours plus 12 hours plus 20 hours is 34.25 hours. Mass is equal to the ln of t, so the ln of that time, 34.25 is 1 over 2.8299, which is approximately equal to 1 over 28.3, which is equal to 1 over 4 root 2. So it's 1 over mv. Mass is 4, we know from mass theology. And root 2 is the velocity when velocity equals acceleration equals the position. So now we apply our chemistry equation. PV equals nRT. PV divided by nR is equal to the T, the temperature. 20 times V over 8.31, which is R, is 23.18. So we just saw that. That's the ln of 23.18 is pi. So the exposed area of the cylinder is equal to 2.120 divided by the 96.3129, 9.24 days. So there's a clinker that manufactures cement, a very crude drawing, but it gets the idea across. And it's the rates of change as the cement moves up the clinker. We see a delta temperature between T equals 1550 degrees Celsius, and the temperature at the end is 450 degrees Celsius. It's 180 meters long for a clinker, and so delta T is equal to the difference in temperature between one end and the other is equal to 1100 degrees Celsius. Total energy is equal to 1.5 mc squared. That's just potential energy plus kinetic energy. Mc squared plus 1/2 mc squared is 1.5 mc squared. So we take that 1000 as the heat and divide it by, bring the 1.5 over, divide it by is equal to mc squared. M is equal to 81.5. 81.5 is almost 81.6, which is the left-handed version of the root of the golden mean parabola. Haven't quite figured that out how that works, but there seems to be that numbers can be read from left to right or from right to left. It doesn't matter. Where they meet is where it's important. So 180 divided by 1 over c squared is equal to 20, and ln of 20 is equal to 3. T equals the time, which equals the mass. When time is 3, you know you have y equals y prime. Function equals the derivative. The water to cement ratio, we have H2O is 18 grams per mole, which is 108 grams. And 108 grams divided by that 81.6 is equal to 4/3, which is your space. That's a variable from astrotheology. 1 over S is equal to 75.26%. And the water to cement ratio is 0.42 is the standard water to cement ratio. 108.414 divided by C is equal to 0.42. C is equal to 264.4, which is equal to 1 over 378. 375, 1 over 375 is equal to the superforce. 8/3, so 2.67. So for mortar, we have the porosity of mortar. We have to rejoin masonry joints every every 20 years or so in order to preserve the masonry. It's a lot of work cutting out the mortar joints and replace them, but we'll just consider briefly here mortar. So pH from acid base in chemistry is equal to the log of the molar concentration of H plus. pH is equal to 12. Mass is equal to ln of T. So we say T is equal T is equal to the moles of hydrogen. So T is equal to 162.7. 1627 divided by the atomic mass of hydrogen, 1.0074, equals 1.618 approximately, which is the golden mean. And hydroxide ion is 17. It would be 16 plus 1, 17. And Avogadro's number here is equal to 102.429. Calcium is equal to 20 times the Avogadro's number is 20.46. The sum of them equals 222, which is the ln, and 9.24 days. So the 36 hours is 1.5 days times 1 over 18 is 2, and plug 2 into the golden mean parabola. 2 squared minus 2 minus 1 equals 1. T equals minus 1 or 2, so time can't be negative, so its time is 2. So the heat of hydration, we have the 15 minutes, which is a quarter of an hour, plus 2 hours, plus 12 hours, plus 20 hours is 34.25 hours. 1 over 34.25 times 1 over 18 is equal to 1622, which is approximately equal to 1618, 1.618, which is the golden mean, which is the root, which is time. So the rate of change, the derivative of the golden mean problem is 2t minus 1. So 2t equals 1622. T is equal to 811, which is approximately equal to 81. And mass is equal to 1 over 81. So energy is equal to 1 over T, which equals 1 over 81, which is equal to 0.01234567, which is equal to the mass. So we plug that 0.81 into the golden mean parabola, we get 1.18 squared minus 0.81 minus 1 is equal to 1.1539, approximately equal to 1 over 866, which is 1 over the sine of 60 degrees. And that's familiar from astrotheology. Space is equal to time, energy is equal to 1 over the sine of 60. So here's a plot of the water to cement ratio versus strength. And this is the formula, the equation of that line, 1 over x minus 1. So that evokes the golden mean parabola, which is x is equal to 1 over x minus 1. So we'll see. So we have 108.414 divided by c is equal to e to the minus 3, which is e to the minus t. C is equal to 2.177, which is equal to 1 over 0.459. So we take the 2.177 divided by the 6.2023 Avogadro's number, we get 361. If we plug 361 into the golden mean parabola here, we get 12308, which is approximately equal to 1 over 81, which is the mass. And the temperature is equal to 1550 degrees Celsius. So we use the ideal gas law for the air that's in the mortar. PV equals nRT, T is equal to PV over R. 1550 divided by 20 times V divided by the R, 8.31. V is equal to 664.025. So the volume of our cylinder is 3.1597. So the volume of 3.1597 divided by that volume is equal to 461.5. Plug that into our golden mean problem, we get 1.2478, which is approximately equal to the minimum energy minus 1.25. E min on the golden mean problem. So C is equal to mass equals the ln of T is equal to 35.197, and E to the 0.35197 is equal to 14218, which is equal to 1 over 0.7033. 1.4218 equals 1 over the water cement ratio, which equals root 2. Water cement ratio is equal to 0.4218, which is approximately equal to pi minus E, Young's modulus, or a number I call it Q's. I get this pen to work. Sorry. Anyway, the C is equal to E, and mass is equal to C, equal to the ln of T equals 1. T is equal to 2.718, or base E. So that's pi minus base E is 0.4233 down here. And the water is 2 hydrogens, there's 2, and an oxygen is 16. The sum is 18 for water, molecular mass. And 5% air, which is nitrogen, hydrogen, oxygen, comes out to 62 is the sum there. So 62 divided by 18 is 1 over 29.2903. So you get a 3444 times 4218. Excuse me. Equals 343.2. Plug that into the golden mean parabola, we get 1 over 81 times 2.5% air gives you 858. So there's the golden mean parabola we've been talking about. The minimum value here, minus 1.25, occurs at t equals a half. The roots are 1.618 and minus 0.618. And there's the formula for the golden mean parabola. So going back to the heat of hydration plot where they had the spike and then the Bell normal curve, we have that equation, which is the Bell normal curve, 1 over the square root of 2 pi times e to the x minus x bar squared all over 2 times the variance squared. And when we plug our figures in, we get it's equal to 0.400, which is 1 over 2.5, which is 1 over the air content in concrete. So this, of course, is the golden mean parabola again that we just saw in figure 5. We plug 0.4 into the golden mean parabola, we get minus 1.24, approximately equal to minus 1.25. Then we have mass is equal to the ln of T, 1.24 equals ln of T. T is equal to 0.289, which E equals 1 over 346. Y is equal to 1 over x minus 1. 1 over 28,938 equals 1.40722, which is approximately equal to root 2. Root 2 is the radius of the circle for sine and cos, and they're equal. So we conclude this long talk, 28-minute talk. We see how AT math can be used to put concrete from Portland cement on a theoretical footing. There are rounding errors in the calculation that could be improved upon by more careful analysis. So anyway, that's the talk for today, and here's your references if you want to see them. And I hope you've enjoyed the talk, and that's it. Thank you very much.